Okay, Mr. Amos, you can go ahead. Mr. Amos. Hello. Mr. Amos, if you are speaking, we can't hear you.
Can you guys hear me?
Yeah, we can hear you now.
Somewhere, if you are talking, you are not audible. I can't hear you very well.
Okay, can you hear me now?
Okay.
You can go ahead.
Okay. Okay. What's happening? My microphone is not picking. Let me see. Hello? Samuel, can you speak
Yeah, we
again?
can hear you. We can hear you
I can
clearly.
hear
We
you.
can hear you
Okay.
clearly.
Okay. I don't know. I'm not able to hear. Hold on. Let me see. You guys can hear me, but I'm struggling to. Okay. Samuel, can you speak again?
Okay, yeah, we can hear you. We can hear you.
Okay.
Can you hear me?
I can hear boys fan, but it's okay. Let me continue. So you asked what
Okay,
is
please.
um you were
Platform
asking
transaction manager. Yes.
what platform transaction manager means, right? So if you have if you if you have for example, if you have for each database you are going to have a platform transaction manager. A platform transaction manager. So let's assume you have so basically it just help you to um, actually what you are seeing at transaction annotation is just a wrapper around the platform transaction manager. So for each database you have in your Spring Boot application, you are going to have one corresponding platform transaction manager. So it basically handles the begin of transaction, the commit and rollback. So you can actually call this guy to do all that for you. So that's the role. So if you wrap it like this, it means all the rollback, begin transaction, end and all is going to be handled by the platform transaction. So let's assume you have two database. Sometimes you have a need to do that in your application. You are going to create your own platform transaction manager and wire it with your data source. So for each data source, you need to have a corresponding platform transaction manager. So that's just what it helps you do. You can check it out, but these things are things we should be able to know, because it helps in how we solve this problem. So that means I'm not comfortable. I don't know. I'm not hearing us.
I can hear you clearly.
Give me a minute. Yeah. Okay. So did I answer your question? All right. You can just give me a thumbs up, then I know. Uh, okay. Perfect. All right. So let's move on to the next slide so we can discuss. So this is good. This looks good for me. This is a good solution, guys. But let's look at what happens, right? Next. So let's see what can possibly be another challenge we can have. All right. So now the next question is, what if, just like my friend said, Mark, right, when he was talking about millions of records. So Because we have millions of records, we don't want one cron job to be able to do this. And not just because of that single decision, but maybe we have other APIs that this application is also supporting. And then we need to scale horizontally. We need to spin multiple instances of this application, right? Now, multiple instances of this application means that we can process the millions record more faster, because each of the application is going to have its own cron job. We are only meeting at the database, as you can see at the right hand side here. So I have instance 1A and instance B on my instance. Then all of them are hitting the database and trying to process. Now, at this point, I'm going to have a lot of issues, right? What issue can we think of? The one that is very clear, race condition. Because at this point now, if I have two instances of this application, it means I have this cron job running in the instance A and instance B. And there is a high possibility that these guys are going to start processing the record at the same time. Then it means that if you fetch row 1 to 50, then B will also come and fetch 1 to 50 and start processing. Then it becomes a problem. But what I actually wanted to achieve is I want to have high throughput by spinning multiple instances. But if you check your logs or your monitoring tool at this point, you discover that it's the same work time you are doing, mutation, data, everything is just messed up right now. So how can we do this right? That's another thing. So we have duplicate orders. You can mention them. All the issue associated with concurrency, you will have it here now. So how can we address this? So let's go to the next slide. So this is the point. There are so many other, before I show you this solution, right? If you are in an organization at this point in time, you need to be very careful, because smart engineers will come to you and tell you, okay, can we do Redis locking, distributed locking, stuff like that. Complex architecture, no, you don't need to do that. Very simple solution. Stick to your database, Postgres and your Spring Boot application. We can solve this. But we need to understand basic concept here. When it comes to locking, and you can, some people will tell you, okay, why don't we can synchronize this method, right? Let's synchronize this method. Synchronization will not help us here, because we have multiple instances. So why are we synchronizing? That's not a good choice. Distributed locking is too complex for this kind of solution. So these are suggestions you might get. So know what you are solving. Try to understand the problem. What are we optimizing here? So where can the solution come from? The solution can come at the database level. Why don't we lock this database by each instances? So can I have a way of making A to select certain number of rows and process without interfering with instance B? While maintaining high concurrency? And we do that. Yes, we can. All right. So how can we do that? Now, this is where you need to understand isolation level. When it comes to database locking, there are basically two types of database locking, right, guys? We know we have pessimistic locking and we have optimistic locking. I will not go into details, but I want you guys to find time after this and look at that. I will explain the approach because we don't have time here much. So, but I will explain at the highest level. Optimistic locking is, let's say, is a kind of when you have when you have two transactions, both of them can you put a shared lock on the transaction. Shared lock means that two transactions can read the same row and try to process it at the same time. So the only problem comes who commit first. So in Postgres or in Spring, the way we do that is your entity must have at version annotation. Or at minimum, you can have, you can still implement it using this login, what do you call, audit feeds, like updated, at created, and or you can use that to implement. But the easiest way is you will have an annotation on your entity called at version. So for optimistic locking. So what it means is two transactions can fetch the same record, but one will commit first. So if one commits ahead of the other one, then the second transaction will be rolled back. Now, this is a good choice, especially when the amount of work in between. Remember, when you select an object, that object is cached at first level. You process it, do your updates. That forms a single transaction. Now, if that unit of work is not too expensive, you can consider to work with optimistic locking. It will be the best approach. But what if the work you are doing when you pull this record from the database, you are doing a lot of logic? Then using optimistic locking will be a terrible decision. Why? Because if you have about 3 transaction threads, or let's say 10,000, all of them are going to pull that single record, and all of them are going to execute this amount of work on that entity. But it's only one that is going to get committed. So you are wasting CPU time. So this is where you consider something else. But if your use case, if you are just pulling, doing nothing, and then you are just sending back, then maybe you can also do some retry to make sure that if you really want each of them to commit, then you do retry again. So guys, you read more about optimistic locking. But this is the scenario where you can use it. Does that make sense? Yeah. So pessimistic locking, this one is what you are going to have on the entity. It means is similar to synchronized. Do you know synchronized keyword? Yes, I believe most of us should know. It gives you is not flexible. It means one transaction is going to read per time, and only one transaction is also going to commit. Now, pessimistic locking is not good enough because this is going to, if you have multiple instances, it means they are going, other transactions are going to wait. Now, when other transactions are waiting, it means that you can have deadlock, right, guys? So you have to find a balance. So these are the two ways you can lock your DB. All right. So let's see how we can approach this in a way that we can be able to have high concurrency, but at the same time, we are also not keeping other transactions waiting for a long time. So any question at this point, especially here, is there any concept that is not clear? Is there anybody that does not understand this problem that we are trying to fix right now? Okay, I take the thumbs up as we understand, we're on the same page. Excellent. So now how do we solve this? Most times when you get to the interview, people are quick to say, let's use this select, update, Yes. How do we get here? This is what I need to clarify. This is what we are learning here. I believe most of you must have seen this SQL query, select all from product where quantity is less than threshold, and update skip lock. First of all, if you want to do pessimistic locking, then this part where you have skip locked is not going to be there. You are just going to select for update alone. This part of the query is not going to be there. If you remove skip, sorry guys, if you remove, can you see the SQL query on the board, on the slide, right? If you remove the skip lock, then what you have is pessimistic locking. It's going to put a exclusive lock on each transaction. Exclusive lock means one transaction per time. Once I acquire, all other ones are going to wait for me. But with skip lock, it means what I'm telling the database now is, if you select these first 50 records, then put an exclusive lock on these 50 records. But now put a flag on them telling other transactions that these guys are already acquired. So when you see this record, skip it and move to the other one. Don't wait for me. Don't wait. Continue processing the other records. So at this point, you will now get a desire. So let's assume you have 100 records to process. The first thread, the first cron job start and pick 50. Another one coming will start from 51 to 100. That was the desired output. That's what I wanted. In this case, I'm going to achieve high concurrency. I'm not waiting. I am also going to achieve high throughput, because if I have 1 million records, multiple instances, we'll be processing them in parallel. Are we learning something, guys? Yeah. So see what I do here. Now I want to show you. There are some people that don't like SQL queries, right? Yeah, Jonathan, I'll come to you. There are some people that don't like SQL query. So what they will do is, there is this annotation called at I think it's query hint, right? I'll show you guys in code. You can use that to be able to achieve this in Hibernate, but please don't do that again. It's not acceptable, because at query hint annotation was not meant for this, so it's an abuse. So if you check your current Spring JDBC, this is duplicated. Don't use that. Please write your SQL query. This is the save and the standard. All right, guys, do it this way. So I define a new method. I call it find low stock for update skip. I give it a good name. And then I write my SQL query to bind it. Now, I now call it in my method. So this is what we have. Skip lock rows. If instance lock row, this is not looking correct, but this is 1 to 50 instance. Be skip then, I immediately proceed from 151 to 100. No blocking, concurrency, very high concurrency. We have achieved that. And it guarantees safety. So let me take Jonathan's question before I move to the next slide. Over to you.
Okay, yeah, thank you. So the skip lock.
Oh, guys.
Hello, can you hear me? Hello, can you hear me?
Jonathan,
yes,
sorry,
we can,
I
Mr.
cannot
Jonathan.
hear you.
Okay, so yeah.
Let me check my microphone. Okay. What is happening here?
So my question is, the skip lock is used to.
Yeah, I can hear you now. Start
so
again, please.
Yeah, my question is, the skip lock is used as a flag to tell the other instance that that 50 rows has been acquired.
That's correct. And you should know it's also like a command. Don't wait for these 50 records.
Okay.
Please process to the one that, because what happened here is that you are putting an exclusive lock. So understand this. There are two types of lock you can put on a transaction. You can have a shared lock. If you have a shared lock, it means two transactions can read the same record, okay? But if you have an exclusive lock on a record, it means it's only one transaction that can read it. So here the 50 records are going to have exclusive lock. But in addition, they are going to have that flag, like a metadata, telling other transaction, this guy is only acquired, you move on. That's the logic. That's the magic here. Very simple. Make sense? All right. So let's move to the next slide. Now, this looks good, in my opinion. Good? Everybody is happy? Praise me, thank you. Everybody is happy? This is happy. Maybe your line manager is happy. Super proud of you at this point. Okay. Good job. Good job. Now, but one more problem I see here, guys. One more problem. So there is something we have not handled. If you look at this code right now, we are having round trips. When we are saving, remember, we are saving each record. For each 50 iteration, we are saving like 100, updating 100, and we are saving 100. I mean, we are saving 50, and we are updating 50. So we are having like 100 calls to the database. Did anybody see this? Can we make it better? Let's go to the next slide. I'll show you what I mean. See what is happening? Without batching, if I didn't batch this, what is happening? I am processing 50 products. I am updating 50, and I am saving 50 also for the stock, right? So this is what I'm having. Round trips, 100. How many of us, just when we have our YAML or YML, we just connect to database? That's all we do. We don't care about these other flags, right? But these are very important at times. Especially in this case, I can set a batch. Since I'm doing top 50, I can say, okay, the batch size is 50, right? Then I'll say for insert is true, for update is also true. Then that will give us, with batching, instead of 50 round trips, we are going only 2 times, because Hibernate will now accumulate them and flush at the same time. Make sense? So, high throughput. I will share a link to this report, and then you guys can check it out. Because I did not include, I've not pushed the code up. So thank you guys so much for being here with me, and I hope we have learned a lot. So I'm also acknowledging Rafael Ponti. This guy is a Brazilian software engineer. He presented something similar in Spring IO 2024. You guys can go there and check this out. Maybe he must have explained better than I do. Thank you.
Wow. Thank you very much, Mr. Amos, for that wonderful presentation. Thank you very much. For if there is any question now, please you can ask a question. But I think most of us have asked the question during the presentation. And also the slide and the code base, as Mr. Amos has mentioned, will be provided for us. Will be provided for those of us that wants to go. So and we also both this particular session is recorded, and we'll get it on YouTube for our learning and learning. We also have the medium well drafted article out, so we can go and also read the article also. So I want to appreciate you for already taking lots of our time as I'm rushing here. So I really appreciate each and every one of us for being part of this particular session. And Mr. Amos, we really appreciate the time. Thank you very much for this wonderful presentation. Thank you very much. And I believe this has actually deepened our curiosity as to distributed system and this is quite complicated. I was confused, but definitely it's worth digging in. Definitely it's worth digging in, and this is what makes a senior developers, you get, and we are still going. Thank you very much once again, Mr. Amos. Really appreciate. Oh, Mr. Amos, yeah, you can say. Yeah, Mr. Amos, you can speak, please. Oh, I thought you wanted to speak. I think okay. Okay, thank you very much. We can should have a good night rest, and we meet again on Tuesday. And again, please, before we go, our first DSC session for this year is starting this Saturday, so watch out for that. And our monthly session, we are going to get those updates tonight, so just look out for that. Our DSC this Saturday. Don't forget. So have a lovely night rest.
Bye, guys.
Bye, guys.